Hello everyone, Ikshita Agarwal here, roll number 20 CE30012. So today I'm gonna show you the working of DHT22 humidity and temperature sensor using Arduino in the Proteus demonstration. And here is our Arduino board 328, the terminal and push button and the humidity temperature sensor. Now let's look at the source code. So as per the given conditions, I modified the code to the given temperature and humidity conditions. Now let's run the code. So here temperature is less than 15. So as per the given condition, the LED is blinking. Now as we will increase the temperature, the second condition will prevail now as per the new humidity and temperature, and accordingly rest of the conditions will follow as well. So in next part of the assignment, I'm going to build an oscilloscope using Arduino. So here's the LED connected to pin number 13, and now let's look at the source code. So here is the source code, and I have set the pin number 13 as output pin, and I have created a loop on this following functions. And now let's build it, and it's already compiled. So let's play it. So as you can see, the LED is blinking. Now let's see the waveforms in the oscilloscope. I'll connect this terminal D to pin number 13 and let's play it again. So as now you can see in the oscilloscope, the square waves are generating. So yeah, that's it. So as for this activity, we are going to do loop control on DC motor using Arduino in Proteus stimulator. So this is our Arduino 328 and motor shield, and this is our terminal, some push buttons over here, and this is our IC, which is H bridged L298, and two motors connected to channel A and channel B. For channel A, output source are 1 and 2, and input source are enable A, input 1 and input 2. For channel B, output source are output 3, output 4, and for input enable B, input 3 and input 4. So now let's look at our code. So here in this code, I've put the PWM value as 100, and for the output, this 12th pin as in input 1 pin, and we are going to perform loop on the pin 6 for PWM value 100. So PWM value can range from 0 to 255. At 0, the motor doesn't work at all, and at 255 it remains on, and for middle values it's directly proportional to the voltage. So let's run our stimulation. So as you can see, the motor has started to rotate and the voltage is increasing continuously, and it's gonna increase until it reaches a stable value. So as you can see that the voltage has reached a stable value. So yeah, that's it. So in this part, I'm gonna use the Node-RED for creating an interactive dashboard, for first of which I'll be creating a water level controller dashboard, and for that I'll use a slider gauge and rename this slider as water level controller, and here controller, and maximum range I'll use 100 in one step. It's all done. And next I'll rename gauge as water level controller in centimeter, and I'll use the range up to 100, and color for color differentiation, green 60 and red, green 30 and red 60. Okay, so done. And I'll use a connecting wire to connect both of these, and for the next part I'm gonna use to make a gas pressure controller, and for that I'm gonna use again a slider and a chart. Slider I'm gonna use new name, gas pressure controller, date, add, and gas pressure controller. I'll use this range up to 40, and done. And in chart I'll rename this as gas pressure controller in bar, and I'll use the bar chart for this, and minimum 0 to 40 maximum, and that's it. I'll again use a connecting wire to connect both of these, and then I'll deploy it. Now see, so here is our water level controller as well as gas pressure controller. Now changing the values here will change this graph, as well as here also changing the value will result in this change. So that was the end of my activity. So that was end of my activity. Thank you. So that was end of my activity. Thank you.